Percentage yield is a calculation that we can do to find out how much of a product has been made compared to how much we thought we should be making. So, for example, if I'm trying to make a reactant into a product, I would expect to be able to calculate what that is, because we know no atoms are created or destroyed in the reaction, so the mass of the reactants must equal the mass of the products. But unfortunately, there are some reasons that actually we don't always get what we expect at the end, and some of the product is lost for various reasons. It's very rare, in fact, that we have a percentage yield of 100. So the reaction might be reversible. Here's the Haber process. The reaction is reversible there. We can put nitrogen and hydrogen together. We can put the temperature and the pressure towards the optimum conditions for it, but we're not going to get all of the nitrogen and hydrogen converted into ammonia, because there are two competing reactions. One of them is going forwards, one of them is going backwards, and therefore not everything is going to be converted into ammonia, because some of it's going to be converted back. Also, if we have made our product and we then need to separate it from, for example, other things that we had in excess, like from filtering or from distilling or something like that, there's always going to be something left in the filter paper or on the glassware, and that's going to reduce the amount of product we get, because some of that stuff stuck in the filter paper or on the glassware is going to be your product. So the final thing that can happen is we can get slightly unexpected reactions, and maybe there's an impurity in the reagents that you're using, or maybe there's just something that you hadn't thought of might be happening in the reaction mixture. For example, a solvent might be reacting with the reagents. Unexpected reactions reduce the percentage yield down as well. Here's iron sulfate reacting with magnesium, and iron sulfate reacting with magnesium is an example of a reaction where there are some side reactions going on here, as well as the one that we actually see there at the top. So let's say that we put in a certain amount of magnesium. Let's say we put in a mass of 0.5 grams. We can calculate how much iron that we're actually going to produce. So we can do that by saying, well, mass over relative mass gives me the number of particles in moles, and so 0.5 grams over 24 from the periodic table gives us 0.02083 recurring moles of magnesium. Now, if we know that, you'll notice that here, up at the top, we don't have a number in front of any of these chemical species here, which means that we're in a 1:1:1:1 ratio. We have one particle of iron sulfate is going to make one particle of iron, one particle of magnesium is going to make one particle of magnesium sulfate, etc. So we know that if we have 0.02083 recurring moles of magnesium, we're going to end up with the same number of particles of iron. And if we know the number of particles of iron in moles, then we're going to be able to work out the mass that we're supposed to get by multiplying moles by relative mass, and the relative mass of iron is 56. So we should be ending up with 1.17 grams of iron. That's what we call the calculated yield, or the expected yield, and that's a theoretical calculation on how much we should get if everything went perfectly, but for the reasons I've already mentioned, it never does. So what's percentage yield? Percentage yield is, well, for example, if I only got 0.76 grams, how much of the expected yield is that as a percentage? So we would call the 0.76 grams the yield, and we would take the yield and we would make it into a fraction of the expected yield by using this equation here. So the yield over the expected yield, we've made it into a fraction, multiplied it by 100 to make that fraction into a percentage. Okay, so Here's the specific example. 0.76 was our yield, and 1.17 was our expected yield. Multiplied by 100 is 65%. So here's an exam question that you might come across. A student burns 0.1 grams of magnesium in oxygen. After the reaction, 0.12 grams of magnesium oxide is produced. Calculate the percentage yield. Right, so the first thing we need to know is how much magnesium oxide should we be getting, and we can do that by working out how much magnesium we've used, which is 0.1 grams of magnesium over 24, which will give me 0.00416 recurrent moles of magnesium. We then need an equation. We can work out from the equation that because this number 2 and this number 2 here are the same, for every 2 particles of magnesium we make 2 particles of magnesium oxide. Therefore, for every 1 particle of magnesium we make 1 particle of magnesium oxide. So we know that we're starting with 0.00416 moles of magnesium, so therefore we will get the same number of particles of magnesium oxide. Now if we want the mass of magnesium oxide that we're expecting, we simply take that number of moles and we multiply it by the relative mass of magnesium oxide, which is 40, and that would be 0.17 grams of magnesium oxide. That's our expected yield. So if we take our yield and our expected yield, we can put those into an equation. Yield over expected yield multiplied by 100 is 0.12 over 0.17 multiplied by 100. 70.6% is our percentage yield, which means that about 30% of one of our reactants is going somewhere else. And the idea is to try and get that percentage as high as possible. And if we have competing methods of making a chemical, we want to choose the method which gives us the highest percentage yield.